Hello, welcome to part 3 of What Does Energy Cost? In this one we're looking at the cost of energy in proportion to the economy as a whole. The big question is that we have choices for the future and there are alternative pathways that the system could take. The question is, how much do they cost and what does that mean, and how do we use that to think about what decisions we make? Start with a bit of context. How big is energy in the economy? Well, if this is the GDP of a typical developed country, then the annual spend on buying energy by businesses and consumers is about 10%, slightly lower. The investment in energy infrastructure is about 1% of GDP. We might use this to note that the shockingly low number, little dot there, can you see it? The R&D investment is 0.03% of GDP, and that has halved over the last 20 years, which doesn't seem to be the right direction of travel. We've just put something on for a comparison here, which is the defence spending. It's about 2.5% on average for the 15 largest economies. So, as we noted before, there are 3 different elements of what makes up energy cost. As we shift from a dirty carbon dioxide and climate change inducing system to a clean system, we tend to get rid of fuel, we tend to increase investment. So there's not necessarily bad things, but there are dynamics. And by the way, I'm using a wind turbine here as a symbol, a logo of a clean energy system. Of course there will still be fuel, but the majority of the system will not be, or at least we know that we'll be using less fuel than today. And that goes even for nuclear, for example. The cost of fuel in nuclear is so small as to be practically irrelevant when it comes to considering the cost of energy from a plant. So let's look at some data. We want to know, obviously we want to try and keep energy spend low, and we know that energy investment is going to get bigger, probably. Here's a good source of data, the Department of Energy and Climate Change 2050 Pathways Calculator. Here's the web link. Fantastic tool, allows you to play with alternative pathways. They have added a lot of cost data recently, and they published costs of a number of scenarios as a result. Now, of course, anybody else can do that too. What they've done is they've added up the investment, the fuel and the O&M over the period to 2050 and then discounted it back to today so you can compare it. And their numbers represent the total cost of the energy system per person per year. So they've said the cost today, according to this methodology, is about $3,700. A business as usual price for the system overall to 2050 is about 4,700. Now, that of course is based on assumptions about what happens to fossil fuel prices, but arguably they're quite conservative assumptions because they stop rising after 2030. And given oil price scarcity, we don't even know whether business as usual is really achievable. But there's a central clean scenario. It's slightly cheaper than the business as usual, and we have another 3 clean scenarios using different things, which are slightly more expensive than business as usual under this study. So the important thing is that all of these costs are well within the margin of error for something looking over such a long period of time and with such great uncertainties. It's more or less saying that in the long view, whatever we do, the energy system is going to cost about the same. Let's look at some other data. Here's from the US, from the brilliantly titled Reinventing Fire from the Rocky Mountain Institute, which is mostly about energy efficiency but does contain a chapter on the electricity system in which they cost the total electricity system under a number of different scenarios. Again, we've got a business as usual and we've got a number of different scenarios. Doesn't matter what they are at the moment. But what's interesting is that they've broken it down into the different categories of spend. So we have investment, transmission, which is effectively investment, fuel, and operation and maintenance. And we can think about the different categories and whether they're good or bad for the economy. So O&M more or less stays the same, generally a good thing, spending on people and kit. Fuel spend, is that good for the economy? Probably not. Most economies are fuel importers, and so that generally means that another nation is benefiting from your spend. And of course this is a big driver of policy in the US right now. So fuel spend does go down under all the clean scenarios. The investment does go up under all the clean scenarios, but is investment a good category in the economy? It means that we will have a much larger pool of low-risk, fixed return or nearly fixed return investments, which doesn't sound like altogether a bad thing. I think overall we might conclude that energy pathways have similar total cost, and that actually cost is not the most important criteria in making our decisions. Thank you very much.